about today is a little bit how to build great data products, but also about data products culture and some of the things that come into our way through these metaphors on how we build data products. So a little bit about me first. My background is in computer science, and I came to data science through network analytics by building Gephi. And most recently, I spent 4 years at LinkedIn in its data products team. So our mission was specifically to leverage that immense amount of data, very interesting data set that LinkedIn has, and come up with new data products. So before we dive into the sins, I wanted to do a quick introduction on data products. And I have a tentative definition up there, but I think there's 3 important words there are user-facing, production, and automated. User-facing because a data product has some kind of interaction with the user. And often it's a feedback loop. It's not just like an algorithm. It's a system that interacts with the user. Production because it scales to live traffic. It's not just a one-off analytics. And finally, automated because it goes beyond business rules. It's based on statistical modeling, machine learning, and so on. And where can we find data products today? Everywhere. And some might argue that everything eventually becomes a data product when you try to do something really, really well in a personalized way. So classic example with Amazon recommender systems. They're still being improved upon today with concepts like diversity. But what we see more is data products more embedded in the user flow, like this example with Pinterest search query categorization. And also we see more and more data products in other industries, like banking with Lending Club example here, or health, safety, transport, and so on. And that's interesting because it means that we are learning new domain knowledge, and we're also taking more risks because some of these industries are affecting our lives much more than the internet industry. So let's now move to our sins and introducing pride. So the story here is that we are data scientists. We are the sexiest job of the 21st century. And yes, there's a huge demand for the profession, and many of those are data products role. And this trend will continue to grow in the next few years. But sometimes we feel that we have superpowers, that we are Superman. And that can have some negative consequences. So how do we, what are these consequences, and how do we keep our feet on the ground? So let's take a step back first and realize that I think there's still a lot of work to do. We still don't really know which education is best for children. We still don't have a lot of inefficient administration. The job market is also very inefficient. The skills gap problem, for example. And I think, as an example, it's our responsibility today to take action on this modern data deluge. And we are partly responsible for that with always more recommendation, more articles to read, more content to engage. But what the user really wants is not more of everything. It wants the data product to understand its needs and to sort of do the job for them. And also an important call to action when building data product is to understand for who are we building this data product for. Are we building it for ourselves, or are we building it for the user? And that's important to internalize because our needs, data people, are very different from the user's need. And for example, that came up at LinkedIn very often, where the set of problems of users that have 20 connections are very different from the set of problems of users that have 500 connections. And guess what? Me and all of my coworkers had more than 500 connections. So we could potentially build a product too complicated, wrong, or even embarrassing. Also with pride, there is important to understand the user well and to set expectations. And that's very true when it comes to feedback. If the user takes some time to tell me that this recommendation or this insight is not interesting, it's my job to take that in account, make sure it doesn't show up again, and hopefully learn from it. And with pride, sometimes there's also overconfidence. We take the machine learning, we test our models, we evaluate them, they work, But it doesn't mean that the algorithm won't recommend ridiculous things, right? And that's important because that can harm the user experience, that can even hit the press. Remember that Tim Cook had to apologize in person about Apple Maps being wrong when it came out. And that was probably edge cases in the algorithm that are by now fixed. So it's important when you build a data product to kind of like plan for the worst and be able to respond to that. I can illustrate that with one of my own example. When I was working at LinkedIn on this algorithm for suggesting skills to people, we had a lot of law enforcement skills, like crime, fraud, domestic violence. And it's totally understandable to recommend to a police officer to add domestic violence to his profile because he might be an expert in it, right? But if the algorithm is wrong, that might be recommended to anybody, right? Hi, Sarah, do you want to add domestic violence to your profile? How does that sound? So we did a few things to mitigate the risk here, and we had the ability, for example, to blacklist skills in a matter of minutes instead of hours, and also develop confidence intervals in order to know whether we have enough evidence to make the recommendation. More work up front, but it's actually better to do a few good recommendations sometimes rather than a lot of sort of like various quality. From pride, let's move to wrath. And with Rust, the story is all about anger and frustration when we're trying to build something very quickly. Like we're like in this Ferrari and we get the product out of the door and we want result as quickly as possible. And it doesn't always work. Why? And a good framework to think about how to build data products is the following. When there's three phases, an inception phase, and that's the most important one, a growth phase and a maintenance phase. And notice that there's a dip in the inception phase. That's when you are experimenting, when you are learning, and you can't expect a lot of results at this point because you are going very, very broad. And then with this data that you collected, because the product is already out at the inception, it doesn't mean that you are in the lab cranking, right? The product is out, it's already collecting data, and that will be hopefully fueling your growth phase that comes right after. And with frustration and anger, it's always important to have a plan. Because sometimes, as data scientists, we sort of like, our brain switches into this R&D mode. We are like, oh my God, I need to solve that problem. It's more like a research problem. And that's nothing wrong with that if our coworkers and stakeholders understand the risks. And so it's important to do planning. Actually, it's more important to do the planning than actually have the plan. The plan doesn't really mean anything. The important is the process of planning to socialize the risk of your data product, because not only you have to have the right user experience, but you also have to have the right data. You're judged on that when it comes out. From Rust, let's move to Lust, one of my favorite. So with Lust, we all like beautiful and exciting things. Like this picture of a data center, for example. Isn't it beautiful? Yeah, maybe not. But with Lust, what's important when you have product ideas, sometimes you get into what I call sexy ideas, sexy projects. So these are projects that sort of you would stop everything to go work on those. And that can have some bad consequences. And one way to avoid that is to always perform due diligence, to ask a lot of questions. So when you're in presence of a data sexy project or sexy solution, you ask a lot of questions. And what I mean by sexy solution is, for example, when you apply something too complicated, something overkill to a simple problem. And that can also help you sort of detect when something is just too good to be true. I like this example with so many people were attracted by this problem of predicting the stock market with Twitter data. It's cool. It's also a little bit simplistic, right? And with all these questions, for example, what are the problem are you trying to solve? What is the input? What is the output? What is the model? How did you evaluate it? Can you give me an example of the algorithm failing? With all of these questions, you get a more objective view about the data product, and you can also avoid black boxes. Because black boxes, they will lead to technical debt eventually, and with due diligence, you can better understand, and it's a collective effort, better understand if the algorithm or the evaluation is not transparent or clear. And also to something that reinforces this culture of sort of always working on the sexy project is to forget to thank the people that actually make it all possible, the janitor and the handyman. And these are data engineering and data cleaning projects made by very passionate people who often decide to work on the more laborious things, on the things that sort of benefit all, rather than following the sexy idea. And it's important because these projects also need to be recognized in the company. They need to have visibility. Those data cleaning projects could be fun, actually, very fun. They also need to be presented to the execs. After wrath, let's move to gluttony. So with gluttony in a more like an established product like LinkedIn, you sort of have a lot of different possibilities. You can optimize a lot of different things. And there is this temptation sometimes to just optimize everything. So how do we keep ourselves organized? How do we focus on the right problem? One thing that I've seen very often is when the data science team are spread very thin is the solo data scientist. It's a person who is sort of isolated, working in a vertical or on its own on the product. And that's bad because data science is such a combination of skills. You have people more skilled at coding, some others more skilled at statistics, some others more skilled at product sense. It's really this mix that makes the data products team great. And when you have someone in isolation, not only you may have less robust code because people take shortcuts, they don't share the knowledge as much when they work alone. But you also get just not as a good result. So teams of 3 people, for example, trying to tackle a problem one after another works very well. And talking about the right problem, I think there are a few things that are really important. The first one is the problem needs to be measurable. Remember, if you can't measure it, you can't improve it. Then it needs to be something you can explain, something that you can connect the dots between the end user experience, what the user benefits from, and what you're doing. Then rapid prototyping. You need something that you are able to test, put in production quickly, hopefully in less than 30 days. It's not like just a weekend. The data product takes time. You need to put all of these features together. There's like a whole pipeline to end up with something that the users see. So it takes some time, and 30 days, I think, is a good threshold. Something core. You want your data scientist to work on the most difficult problem. And you want something that you'll be willing to send these guys for a weekend in Lake Tahoe to crank on it. And finally, a problem that you can iterate on, a problem that you'll be able to get something out of the door quickly and learn from that. Hopefully not too bad for the first version, and the first version fuels the second version and so on with the learnings. Finally, let's move to sloth. So with sloth, we just talked about iterations. So when you iterate on the data product, you add new features, you test new models, you experiment, A/B testing, and you also change infrastructure, you refactor. And maybe after 6 months working on your data product, your data pipeline looks like this, where that's actually a real example where each red circle is a pig or Hadoop job. And at this point, it can be really difficult if you don't invest in infrastructure to find a problem, to find a bug, because there's just so many things going on. Was it the data? Was it the model? Was it the code? You can spend hours trying to debug and understand what's going on. So there's 2 things that I want to talk about how to help on that issue. The first one is really using tools like Azkaban or Uzi to make your data pipeline as reproducible as possible. That's important because what you want is the ability to answer a complex question like, why did X see recommendation Y or insight Y, or what that happened? This question will come up because they will be based on how people use the product. And from that, you need to be able to sort of like replay what was going on. And if you have your pipeline just with a bunch of scripts and you're moving that data around on your own, you won't be able to do that. With a pipeline more reproducible, you'll be able to not only understand when, sort of where a bug has been introduced, but also better track what was going on. Finally, on iterations again, you want to do all of these things without making mistakes. You want to be able to take the next product iteration and try a lot of things, and you don't want to push bad data. You don't want to make mistakes, but still want to go fast. So how do we do that? How do we make sure that our data pipelines are robust over time? And the answer to that is really about testing. It's like you unit test your code like engineers do. You'll unit test your data pipelines. That sounds hard, right? Is it really worth? So let's take a look at a quick example where you code, you upload your workflow, you run your workflow, and then you look at the logs, and you do that over and over again. With a more unit-tested version, hopefully you code, and then you code more because you have to do the test, and not only test for the code, but also test for the data, because problems often arise from missing data or bad data. So you have to test for that. And it's a habit. I promise it's actually not that bad. And then you upload your workflow and it just works. When you run it, it just works. So which one is better? Obviously, the one on the right, it's worth investing. And there's actually tools for that, like MR unit or pig unit that can help you do that. And actually, I must admit that some of these tools are still a little bit preliminary, and I think we have a very smart audience here, so hopefully we can get better at that. On this note, thank you very much. Thank you for your attention. I think we have the time for a few questions, no?
Yeah, we could do a couple questions.
Yep, please put your hand up if you have a question.
Any questions at all? Don't be shy. Over there. Okay. I don't know. I'm coming around. So confusing. There we go. All right.
How big is the problem of people providing more and more false data to protect themselves in privacy issues, So young kids are cheating with their names, and all the data they're putting out there are fake data. Is that a problem, or can you clean that easily?
I mean, user input data is always difficult to deal with. You have that's also going back to this idea of anticipating edge cases, right? So when you build a product that will be used by users, it also may be abused by users. So you need to be, your pipeline need to be resistant for that, and you often have to deal with a lot of outliers, and this will burn a lot of your time often. And that's part of the data cleaning process when you start to really understand some of these outliers. But yeah, with users, you always get crazy stuff. More questions?
Any other questions?
I think we have time for one more.
We have time for one more. If someone can put their hand up in a very visible and clear way.
People fixing their hair, throwing me off, thinking they're putting their hand up.
Putting their bags on over their shoulders.
People picking their nose, on their phones.
Okay, we didn't need to go there, Eamon. We did not need to go there.
All
right, let's have another round of applause for Mathieu.